Right. Good morning, everyone. So we are going to discuss one of interesting subject, computational intelligence, which is trending and one of very popular and buzzword in nowadays. So you might learn a lot of theories, concepts, and lot of things in here, and it might be really interesting for you. If you are feeling like if you're going if you're planning to be one of a data scientist, or else if you're planning to become one of AI engineer, or many other factors, there are a lot actually. You could be able to learn and do many things during this subject. The ultimate objective of this subject is giving the knowledge for you. So basically, it's very detailed subject area to learn and understand as much as things in here. First of all, yeah, well, I think Taruko, you can see my screen, right?
Yes, sir.
Taruko,
Yes, sir.
sorry.
Yes, can
Yes, yes,
you
you can
see?
see that. You also
Yes,
can
sir.
see the screen. All right. It's manageable now, so I can do the work very well. Probably there might be a couple of students in this subject. So first of all, I want to give some of interesting subject areas, uh, interesting things for you, and we'll start the discussion. So, right, let's see whether everyone can move this one or not. Right. Thargo, can you see there's a screen change?
Yes, sir.
All right, nice there. Okay, so we'll discuss what is this artificial intelligence. Actually, basically, we want to focus on computational intelligence, one of detailed subject area than the artificial intelligence and data science. But actually, I'm not going to that machine related work. I'm much focused on algorithmic implementations and how it works, how these algorithms might work, and what are the things that we can do. As an example, we are going to discuss different kind of linear regressions, like regression algorithms, supervised algorithms, unsupervised algorithms, and more specifically we have to focus on different kind of algorithmic implementations like naive bayes, decision trees, k-means, and many other factors. Apart from that, last few weeks we are planning to not last few weeks, last week probably we are focusing on neural networks, which is much more detailed. Sometimes it's very heavier work for you. So this is the course for introduction. So I'm not focused on very detailed, very comprehensive work. And in the other hand, this is kind of much practical subject area. So what you need to understand is you need to understand very well concept wise. The conceptualization required, yes, of course, agreed with that. Theoretical part is required, yes, agreed. But for most of the time, it's much related to practicals. So my general suggestion is spend couple of hours per day with this subject. Then you could be able to understand, grasp, and work very well with these concepts and other related stuff. Because just learning theory is not the expectation of the subject. Because once it comes to the evaluation, also more than like nearly half, is totally allocated for a practical. So that means the question is focused on a practical solution. So it's good attempt to give like good starting point today. If you don't know anything, no worries at all. I'm planning to discuss as much as simpler that I can. In the other hand, I can go for more simpler versions, but I believe an undergraduate would be able to grasp and go through the rest of the things. So do the practicals as much as during the class time. I will do couple of practicals, and I will demonstrate you some of interesting stories, what happens in here and there. As an example, how to data pre-process, how to work on, and so on and so forth. But it's much more detailed work that you need to do. Simply, probably week 3, 4, like session 3, 4 around, I will show you two versions that I'm going to discuss and what actually you should do. Because once I'm doing during the class, it's just probably less than 5% of the total work. So 95% is on top of your hands, because this is like learning to swim, learning to drive, and so on and so forth. So the practicals, like self-study, self-practicals are the most important. Once it comes to this driving, you should get accidents, you should get everything when you are driving. Someone is driving, you don't get skill into yourself, right? So you should drive and drive, drive and drive, then you know the roads, then you know the paths, then you know what happens, then you know there's police, there is rules in the road, everything you know. Like swimming again, you know the whole story, right? Unless you are swimming, you jump into the pool, you would not able to learn anything. So that's the whole story. So this subject is like that. So my general advice is code and code. Learn some of theories. Don't spend lengthy hours for learn theories. Probably almost theoretical concepts would be covered during the class time. Apart from that, practical implementations also I will cover, not the first couple of days, but after day 3 onwards, like session 3, 4 onwards, I'm going to do a couple of practicals related to the subject area, so you could be able to uh, work with me, because it's like pair programming. But it's not pair programming, it's just what we can call it's just mimic the same work, right? So you can go along with me while I'm doing, so you can do the same thing. And then you can get all skills into your body yourself once you are doing a lot of practicals. So um, that's the general advice for this subject, rather than the introduction work. So last time also quite lower marks. Marks wise, it's very low marks probably scored to the students. None of the student scored a distinction, if I'm not mistaken. So, so that's why I'm always telling this is very what we call this. It's not hard, guys. It's not hard. It's just what we call lot of practicals are there. Right? Lot of practicals are there. Now, it's not hard subject. You can understand. This is not rocket science, so you could be able to understand. But it's not something easy like project management kind of thing. That means if you just started, go through the lesson and copy pasted something and submit. That's not the story. The story is a bit more different, because you need to solve a problem. Again, it's like solving a math problem. It's like you are doing some mathematics. Don't get upset. No maths in this class, zero, right? So don't worry. All the math was implemented in a code, so you don't want to bother at all. All you need to do is you need to go through these algorithms and implement it, but it should be a proper execution. We have a scientific and systematic mechanism to go through all of these phases. So it's really important to understand these phases very well, to understand and go through all the things. So I will show you the course overview and other stuff. It's just some simple examples. First of all, I need to know how about your programming skills. You have Python skills, Python implementation, programming for the programming, and how about your programming skills? Tharuka, Tharaka, right? Tharaka. How about
Yes,
your
sir.
programming skills, dear?
Uh, I don't know Python.
You, okay. Any other programming language?
Yes, C++, Java, React.
You know Java. That means you know how to define a variable. You know how to call a function.
Yes.
If else statements,
Sure.
huh?
Okay.
That's okay. All right, that's more than enough. I will do like the today evening session, a small introduction to Python, what to install, the IDE, then how to create a Jupyter notebook, a simple Python program, and we'll set up the environment. Plus, we'll do some of practicals like import a package and we'll read a CSV file and so on and so forth. I'm not going to very detailed discussion in the first two lessons. Third lesson onwards, we are going to discuss much more comprehensive work related to this subject. Apart from that, the first two lessons are much more theory and like a recap of programming. Good morning, Tejani. Tejani, you? Right. Tejani, so you are doing, you have experience in programming, Python. Yes. Not, uh, but not, not Python. All right. So we'll do a small work. That means you know if else, loops and stuff, right? All right. That's more than enough. I think you don't want to join since we have everything ready. So no need to join in. Right. The other one, Kavi, I don't know. Kavi, Kavi, are you there? All right. Somehow, that's fine. So we'll continue with the lesson. So the introduction to artificial intelligence, how this intelligence comes to the machines. I will start with one of interesting story. We have ChatGPT. It's a language model. How powerful it is, right? If we ask any question, it gives the answer. It's not complete AI solution. It's just a language model. Still, we have some space to improve. So I think it comes to your head, right? So no need to discuss much more detail. We have a solution, a predefined solution. But actually, what has happened? They collected thousands of millions of words. Then they collected thousands of millions of language styles. Then they train a model. Then they produce something, right? It's something very expensive work that we can see at the moment. But I'm not sure. Like next couple of years, we will get much more advanced work than ChatGPT. So if you hear my uh, semester last semester presentation, I told next semester I would have another interesting story to tell. At that time, there was no ChatGPT. Now I have ChatGPT, one of the interesting story. And I'm pretty sure in next semester, once I'm starting this course, it would be like couple of nice, interesting implementations might be there. Right. So that's not the introduction to AI. That's the introduction to the taste of this AI. Right. We'll discuss each and every step in here and there. So well, I want to give a lesson overview, not by myself, but by one of interesting story in here. We'll see. Can you hear, guys? Can you hear what I'm? Can't.
No, sir.
Yes, sir.
You can hear, right? Can you can? All right, nice. So yeah, It's not clear
No, sir.
because of this noise. Neha. Shall we ask to switch off this one? Hmm? Oh. If it is hot, we will switch on. Right. All right. So we'll continue the discussion. So we have another interesting lesson overview what they're doing. I'm mostly continue this kind of like same thing probably going through here. Right. So you got it something, right? So we are going to discuss a lot of things in here, how these things are working, and how these models was developed, and probably you also develop, not probably, yes, of course, you will develop a model very soon. Within first few days, we are going to start our first model, a statistical model. We are first of all we start the statistical models, then we'll go to much more comprehensive, sophisticated algorithms to implement. So the models will develop by yourself. I just give some basic guidance for you. Right, I think you can see my screen again. Can you see my screen? Yes, sir. Right, because like if it is just online, so it's like just one to focus on. Now I have three screens to shift here and there. Right, come, we'll see how this story starts. It was like 1950. Alan Turing starts the story. The journey is starts with very basic implementation, yet it's very powerful. Even these stuff from proposed by Alan Turing, still it's in the context. That means after more than uh, half a century it's gone, but still some of implementation still in there. So that means it's very powerful, right? So then after it starts another uh, story, uh, perceptron algorithms. Now it comes to the context. After like half a century, it comes to the implementation, how it moves. And some of data sets was learned, and AI applications was started for the general trends. Probably 1980 around, uh, 70 to 80, some of deep learning algorithms was developed, believe, right? Some of algorithms was developed, deep learning algorithms was developed 1970 to 80 around, but those were not much used at that time. The reason behind is the computational power, number of the data sets, the availability of the data sets, people who can do programming implementations, all of these things was a blocker. Sure, algorithms was developed by people like special, like mathematicians, the whole story. Whatever the thing starts with mathematics, right? Even if it is art, or econ or anywhere, if you go last and detailed, that's a mathematician, one of mathematician. That's the whole story. The math controls this world. That's the reality. Regardless of anything, if you go for biology, finally it's a mathematician. If you go deep dive, definitely there's a mathematician who starts something, right? So similarly, in this context also, most of the people are mathematicians. They develop algorithms, they implemented many things, but those wasn't real used at that time. The reason behind is to execute those algorithms. If you don't know algorithm, what is this algorithm? No, don't worry, I will tell. uh, like these algorithms was very expensive. That means it requires a lot of computational power and lot of data to take in here and there. It's mandatory circumstance. If not, it's not working. Hence, even like 2020, 2020, around the story starts. 2010, even it wasn't much come to the context, but after 2015, the whole story comes into the context. We have packages, we have data, and people starts a new world. So they proposed at that time. So think how they are intelligent, right? 1970s around they proposed, and after half a century, half a century, took the real world to come into that place. So actually they was live this time, right? They was live 2022 around. That's the story. But at that time, people wasn't care. People wasn't much considered about these algorithms. But now people consider all of these things very well. And 1985, speech recognition algorithms was, that means natural language processing. See, Siri and stuff comes to the context 2000, after 2000, right? It was implemented 2000, 2005 around. Then even if it's not much stronger, but the first installation, first usage was 1985, before your birth probably, right? So even see, Sri Lankans, like for us, natural language processing, still we are unable to do a lot. They developed again, yeah, half a century back. So see, this is the story that we need to understand where we are and where the world runs. Why I'm emphasizing these stories? Uh, the people, sorry, the students, most students believe these are very complex and you are unable to understand because of the complexity. If it is 1985, people can understand at that time. If the scientists was work, that means you should be able to, right? So now you are in a good technological world. At that time it wasn't much stronger technological world, right? So you must be understand all of these concepts very well, and you should be go through and do a lot. And there were some of implementations from IBM and other, Netflix. So these people started, and 2006 15 onwards, right? Because 2014 around, all Facebook, Google, and people, probably 2010 around, the story starts much more stronger. Story starts, implementations, real world implementations. The reason behind is, again, we have algorithms, we have programming skills, we have data sets. All of these reasons comes into the context. All of a sudden we can process terabytes per second. uh, even petabytes or zettabytes of data we can process a second. But if you take with all the stories in here, right, in here, they have P3 machines, right? So very computationally insensitive at that time. Those are not well implemented algorithms. Those are just not well implemented computers. Those are just basic computers. Even at that time, they was able to send a rocket to moon, right? So that's the whole story that you need to understand. They wasn't do have this kind of very sophisticated computers. Now you have i5, i3, i7 computers and very expensive computation. But this time they have P2, P3 machines. I don't think so. Do you have this experience or not? Believe me, guys. Once I started the life in computer world, it's a P3 machine. It's like a 9 task. We have to wait couple of no around 4 minutes around. We have to wait to Windows 98 to up and work. Right. So it's like very what we call very challenging time. Challenging time. And I feel I started around computer world around 2000 around. My computer world first not very well, but just we purchased a computer in 2000 around. We have purchased a computer. um, it's not a brand new so very sophisticated one, uh, very poor machine, but it it covers most of the thing for us. So that's why I'm telling the, the real world people 1970s 80s they were started the story, but we were started in here. We were started in here, so we are 20 years back probably. So we have to go fast as we can. So you are the people who are the pioneers. You are the people who doing all the work. You are the people who are doing the things, because Sri Lanka probably we have just started all of these artificial intelligence and stuff. So it's not very just started 4 to 5 years back probably. That's maximum. Even the data science master's degrees started around a couple of years back. So that means we are the people who start in this story. We are the people who implement in these stories, and a lot of job opportunities nowadays are creating. If you just go to top jobs or any other place that you like to see, LinkedIn, no, just think there are a lot of data science and artificial intelligence job openings are there. So it's a good opportunity to learn these things. So learn for life, not for marks. This is my motto. I'm always telling, don't learn for marks. Learn for your life. Learn, get some skills. Unless you do have a driving license, but you can't drive. No point at all, right? You have driving license, but you can't drive in road. What the purpose of this license? So you have marks, you have distinctions, but you don't know anything how to implement. No point at all, right? So practical implementations are quite important, especially you guys. Give your maximum effort. Give your maximum effort. Believe me, guys. Even last time I told this subject is very hard, but not the very hard. You have to do lot of effort. Uh, there wasn't much considered, or they considered, but they thought they could be able to grasp. But what was happened last movement, last week there, not last week, after last week, 1 or 2 weeks after completing this course, they got the assignment. Then they spent 1 month and they got really they feel they are really hard to do that subject. Then they got again 3 weeks extension, so probably nearly like 2 months they got the subject, but unfortunately none of them got a distinction. That's why I'm emphasizing, guys, in the first day onwards, do it well, do it well, do it well, do it well. Like every week I'm telling, even if you are not attending, it's not a problem at all. Recordings we have. If you are sleepy, you can go outside and have a cup of tea and come, because these kinds of subjects might be some of students feel it's bit lazy and bit hard to grasp. You know, uh, we are from different genes we have, right? uh, if you for one for fun, one for not fun at all. Some of people do like to math, some of people don't like, they hate for math. So if you are a person who hate for the math, Probably it might be a very sleepy work, very hard work. That's a clue for you. You decide where you are. I don't want to decide where you are, and I don't want to force you to for anything, because you people are undergraduates, you all are above 18, you all decides your, yeah, what happens to you in next couple of years. So it's yours, whole life, yours, your decision. You decide. My general suggestion is, even if you take 1 year, you can't do the assessment if you do not focus on the content very well. Believe me, it's like as an example, we'll give like A level math paper, we'll give not 3 hours, we'll give 24 hours, but the same marks will score. Like, if for a single student we are giving 24 hours, but marks wise it's not changing. The reason behind is there is a limitation that you can do. Obviously, that's it. That's all you can do, right? I don't know how many of you have done A level math. That's all you can do, even if it is 3 hours, or probably a bit more, 3.5 hours. Sometimes few students might get little bit higher than the 3 hours. Sometimes 4, 4, 5 hours. Much most some of students might come up, but that's it. That's all. That's all you can do. I'm guaranteed. Right? So believe me. So your effort is really, really, really important. Emphasizing again. Why I'm emphasizing? Some of students just join, right? They didn't hear. So it's all responsibility to go through the recordings couple of times again and again. If you want to stop, pause, go through, have a cup of tea, come back to the work. No worries at all. We have recordings throughout the time. I'm keeping the recordings, right? So that's the point that you need to understand. Do practicals, and practicals. Keep in mind, this is 95 percentage of practical subject. It's not something easy. If you have done very well from the first day onwards, I don't think so you want even a 1 day extension. You could complete the entire assessment within a couple of hours. Believe me, it's not taking more than 3 hours. It's not taking more than 3 hours. I don't know what happens to this semester. Whatever the question assessments comes to you, I'm pretty sure within 3 hours you could be able to finish it. So for that skill should gain a very right. We'll see some of AI things that you know. I have speak a lot. And any questions, any interesting things that you want to start? Yeah, I'm always starting my student discussions from my screen, right? Where come from left to right. So the student who is in left side get always annoying. If you feel it's annoying, buzz me, message me. Then I'll change right to left. Right? Yeah. Tharuka. Sorry, Tharaka, right? Tharaka. Yes.
Yes, sir.
Anything that you know related to the artificial intelligence, any implementations that you know, any experience that you know, anything to add for our discussion, or any questions that you want to ask?
Nothing.
Nothing. All good.
Yes, sir.
Any AI applications that you know?
Uh, ChatGPT,
GPT. Good.
robotics machines.
Well,
Uh, it's
that's it. Good. Next, Tejani. Ah. All right. Yeah, Tejani. You know ChatGPT for now. Anything, any other interesting information related to the artificial intelligence? Not really. Good. No worries. Next one. I can't see your name. I can see your father's name. Somehow, I think that's the name that I can speak. Veerasekara Mudyan Selake. I don't know the rest. Huh?
Yes, sir.
Jim
Hello, sir.
Jim Callum. All right,
Hello.
Jim Callum.
Hello. Yes, sir.
Yeah, all right. Yes, Gim. How do I name them? Who takes your name? Gim. It's a partial name or complete name?
It's a
Nickname. Partial.
partial name. Yeah.
All right.
Yes, sir.
Yeah, Kalum, let me know anything that you know artificial intelligence related to the artificial intelligence.
Artificial intelligence is uh, it's a virtual mankind something.
Mm-hmm. Good. Okay. Anything else?
Actually, virtual man program without
Mm-hmm.
hardwares. It's a
Oh,
only
without
human.
hardware. Mm-hmm.
Yeah, it's only a brain kind of thing. It's a
Hmm?
program like
It's a program.
uh,
Okay. Okay.
yeah, programmatically working only programmatically up to now.
Mm-hmm.
It can it can make a decision and
Yeah. Good.
self learning and object recognition
Mm-hmm.
and uh, make decision object recognitions and uh, people
Yeah, kind of object
developers,
recognition, natural
yeah,
language processing.
developers developers make develop say various of data models and
Mm-hmm.
some models are specific, they are developed for the specific fields. uh,
Mm-hmm.
chat ChatGPT is like model is a, generalized model.
Oh, it's a generalized model. Okay.
Yeah.
Mm-hmm.
uh, yeah, that's it. So,
That's it. Thanks a lot,
yeah,
uh, Callum.
thank you.
You have given a good effort for this one. Appreciate. Yeah, next, Git.
Yes, sir.
Good morning.
Good morning.
How things are going on?
Uh, good, good.
Can't hear you are in outside.
Yeah.
You're in outside while you are playing the. Yeah, that,
No, no, no.
not really.
I'm not at the home right now. Yeah,
Can't hear dear properly. A bit more louder.
yeah. I go somewhere. You can hear. Yeah.
Sorry.
Good now. Is that
Sorry.
okay now? Is that okay now?
Still not. Still not.
What about now?
Now it is now fine. That's fine. You can continue. Yeah, Git. Any AI things that you know, and theoretically it's something that you can add, and applications that you know.
Yeah. Yeah, it's like something which is similar to human brain or something. It's a program made by humans, but they some programs can self learn and do some have special uh, functions like playground AI can draw something which we explain. They can draw the things and like that GPT like more set AI bot like but they have special function like self learning. We can find information, and also the special thing is they not only suggesting things because like Google they can work more than the Google like they can when we give them instructions they can think and self-learn things and give proper answer for that.
Good. Really appreciate Geet. You have done a good job actually. It's good initialization for us actually. Everyone, thanks Tark, Tejani, who is this? What's your name? Callum. Callum and Geet, thanks everyone. You have inputted a lot. It's good for as a starting point. A small small modifications that I want to do for the. I don't get upset with these what we call elaborations. I want to clarify some of things that you want. I want to what we call clear out if there's something gone wrong in your head. That's why I'm asking all these questions and give you answer. It might be right or wrong. Who cares about these things, right? We have very small number of students, and we just work very friendly. So don't worry. You just answer. It might be totally incorrect. Who cares, right? No marks, nothing will happen. I can clarify. As an example, uh, there are machines do have intelligent. That means hardware is in there, right? Small clarification on that. As an example, if you take a robot, I have seen some of robots do have highly intelligent robots, but they can do they can fire to the perfect place. That's a machine. It's a hardware component. So artificial in a broad range, this computational intelligence, machine learning, artificial intelligence, it's like very common. Like we are speaking general version, it's very common. But if you go for very detailed, those do have different data science, big data, right? Those are in another path. Artificial intelligence in another path. So once it comes to this machine learning, artificial intelligence, computational intelligence, much more like in very high level, it's very common. But in detail, it's different. Right? So we can't simply say that is that artificial intelligence. Artificial intelligence sense all these things, right? I'm telling all of these things in very common because we are in the beginning. So these artificial intelligence or the machine learning or whatever, we can implement it to the hardware. Don't think about very expensive, very sophisticated robots to can many things. There is a robot dog. I have seen a movie, like not a movie, like what we call an advertising something, right? An experimental advertising. You don't want to think about those things. That those might be a bit hard for you to understand sometimes. But I'm pretty sure you heard this intelligence air conditions in air conditions, AC machines with intelligence. How it comes? What they are doing is they do have sensors to detect the existing temperature in this room. If number of people are higher, then we all generate some heat, right? Human body generates some heat until we are alive. So what happens in here, once the number of people are higher, it detects the number of people are higher. So what they have is they have a small trained model, a compiled software, and they have implemented to this hardware. Clear? So we can't say there is no hardware implementation, it's just a software. AI can use all of these hardware, like implementation can be worked on top of a specific hardware. More special situations nowadays, uh, all of these hardware components, like very expensive hardware components, like cars, self-driving cars, they have very intelligent than us even, right? Very well intelligent. I have seen an advertising campaign for a taxi company. I can't remember the country, sometimes UK or US. Taxi, right? There is a self-driving car. So the person needs to jump to the vehicle, tell the place where it starts, where it ends. car will automatically takes the best route, then it drives safely. Still we are not in, right? Still we are not in, because if it is implemented in Sri Lanka, I'm pretty sure vehicle won't move, because motorbikes and three-wheelers and people will, and human will run in here everywhere throughout the roads, right? Unless if it is highways, I don't think so. In other roads, I'm pretty sure it's like Game Parana, it's never guaranteed, right? Then AI vehicle will definitely stop. Unless the other situations like highway, I'm pretty sure at least up to good extent we could be able to run. I'm not sure what happens, but experimentally we should, right? Something. So that's the point of this hardware implementation. It's not just software. It's just not a piece of software. There is a possibility to have hardware to. There could be hardware too. On the other hand, I want to emphasize another point. Sometimes the people believe at the beginning it's just like a Python code. Sorry, it's like a Java code. It's like C# code. It's like Ruby code. It's not. This is like machine learning or AI is, we write the code. Yes, agreed with you. It's we agreed for the whole context that you are telling. Yes, we have to write the code. We have to do all of these XYZ things. Yes, agreed. But the output is totally different than a software. For a software production, once you write the code, you have an exe file or something that run in a specific operating system, isn't it? As an example, if you are writing a jar file, probably you produce as a jar file, right? .jar file or file if it is a web application. But once it comes to in our context, in AI context, we don't have an exe or a jar file or any other thing. It's a model. Clear? It's a model. It's a totally different story than a program that runs every time. As an example, username and password, right? An application to have username and password, but they have to check whether the username and password is written in there. Then there's an authorization part. If it is corrected, it redirects to the relevant page. If it is false, then it stops. There is no intelligence at all. It's just a predefined code to check. You go to the whatever the language that you are telling. You go to the database and check if there is this kind of a username and password. If the username and password, there is a predefined URL to redirect. That's the whole story. That's the thing of a software engineer's job. That's the story of a software engineer. Software engineers, like software engineers is we have a broad range, right? Web application developers, mobile application developers, backend developers, middleware developers, XYZ. A lot of people are there in development environment. All of these people do the same thing. The difference is the device and the language and how they work on and how the number of people log in and some of the things. That's the story. But for us, we don't have that kind of a thing. That means our intelligent application means something that predefined. We written something, we teach something to a context, to a specific application. Then we ask these questions. The questions that this model can answer is only what we feed, right? Only what we feed, it comes to out. You got it what I'm telling? What we teach to this model answers for us. It's like a parrot. It's like a parrot. We teach pettobat kya, then it's pettobat kya, the same thing. If something we ask, then it gets confused. Do you have this experience? If you don't have any experience, just go for 2023 journal article, then ask from ChatGPT. It will confused. It will give totally wrong answer. The reason behind is they trained this model 2021, right? So they have all the information, like nearly 90% of information up to 2021. 22 onwards, information is not in this model. So if we ask what happens in 2023, model will get confused. but ChatGPT is much more stronger. What it does is it takes some of information and at least give up to some extent. As an example, 2024 one, it will generate something. You have you experimented this thing? It can speak in Sinhala. You just go and ask from ChatGPT Sinhala questions. They answer in Sinhala answers. Sinhala questions in Sinhala language. It's nice, right? You don't have this experience because it's a language model. It's a language model. It can at least give some incorrect answer. It don't keep quiet unless if anything not, or else once the model is developed, if the developer told if you do this kind of thing, then this kind of thing. I will give an example. What is this kind of thing? If we ask a bad thing, bad word, some bad words are in the world here. So if we ask what is this, if we get anger and if we ask, right, then they're telling, sorry, I'm a language model, I can't do this kind of thing. Just go to ChatGPT and put some bad word that then they are telling, hey, I don't know anything, I'm a language model. Because once the application developed, once the developers develop the application, they have a set of words. If that is the input, then they tell no output for that kind of thing. If you have Java experience, it's like this is not the perfect example, but some example that you can understand. Switch cases. We have switch, Saman, Kasun, and something. If none of these people are, then we have a default, right? We have default case. So what happens in this default case? If any of these switches are not working, then it comes to the default. The same story happens in here. If none of these answers are not in there, the default case exists. Don't get misinterpreted. I'm teaching default case in artificial intelligence, right? It's a totally different incorrect thing. But for an example to understand for a student, I'm telling that this kind of thing happens. So I don't have anything, so it gives this kind of thing. You got clarified something? I just want to emphasize this hardware related stuff plus the programming. That means once we are developing an AI application, we don't want to write thousands of millions of if else. As an example, you just think I will go the same thing again. We want to classify apple and orange. How to classify? It's very, very hard because those are two different images. So what they need to do is they need to check the weight, size, color, and many things. But as a human, you do all of a sudden. How it comes? Because once you are a kid, you ask 1,000 times, right? You ask the same question a couple of times, then your brain cells was detected very well. Our brain is very powerful, so it detected many features of an apple and orange. Then after a couple of days, you can detect almost what is this apple and orange. All right, got it? Clear? Yes, Kavi. How about the things that you know related to artificial intelligence? Kavi? No answer. Nowadays, if you don't have any answer nowadays at all, but hang on the class. Right? Leaving is not a solution. Right. Well, I think I have clarified some things because I want to emphasize entire day I'm spending to tell again and again and again to clarify these things. Because if it is not clarified, you might get into a big thing. Right. In your terms, what is machine learning? We start from my friend Tarak. Tharaka. We'll go for Dasun. That might be easy. Yeah, Dasun. What is machine learning in your terms?
Oh, machine learning.
Hmm?
It's a
All right. All right. Tejani? Yeah.
I think it develops algorithm
Okay.
and statistical development
Mm-hmm.
in
Machine learning.
yeah.
Okay.
com-
Is this? Yeah, Taruga. That's
com- computer systems to learn and without following experiment the machine learning.
All right. Thank you. Okay. Kalu?
Um,
Yes, Kalu.
machine give for output and input for developer and learn, and the process make the process by machine kind of.
Oh, make the processes by machine. Well, that's too advanced. Well, that's much related to hardware.
Machine learn itself according to the
Machine learn
model
itself. All right. All right. Machine learn itself. We'll see. Right. Today is the first day, ne? So the people believe machine learn itself. After fifth, sixth week, you will tell no, machines can't learn. Right? At the moment, everyone, what we ask, if we ask from a big audience, CEOs, directors, and other people, then they are thinking, okay, machines can learn. Machines can't learn. How a machine can learn? No, no, it's something we have to take a human brain and put into there. Machines can't learn. That's a false information. Machines can't learn. Machines can't do anything rather than our implementations. What are
No,
the
no,
our
machine learn according to the imp, human
yeah input
input,
according to human input?
like human baby uh,
Yeah, like baby.
learning
Good.
like
Yes.
as
Yes. Good. Thank you. That's nice. Actually, guys, you should today or not. The very first thing, if someone asks machine learning whether a machine can decide, no, machine can't do anything. It's just a dumb heart can't do anything. What we can do is we can just give some of information. I may lamya gaya kavi. Hariyanne. Guys, if you can't answer anything, just say I can't give an answer. That's it, right? I'm not forcing you for anything. I'm just asking these questions. You know why? After a while, you get sleepy. One thing, one very important thing is you might get sleepy because you are an online student, right? You might sleep after a while. You sleep. So I want to keep you awake. The other thing is I want to clarify the misconceptions in your head. And I have to create a telegram group. I have a lot of in-class activities to share with you, like programs and MCQ questions and stuff, to keep you awake. The ultimate objective is keep you awake, because from when COVID starts, 2020, 20 COVID, I don't know, whenever it starts, then onwards
19
I
after.
have done 20, right?
Yes,
Then onwards I
19
have done
after.
huh?
19 after.
Sri Lanka, I think 20 January something.
Yes.
Then probably from that onwards, I'm doing online lectures. So I'm well expert in online. Right? So I know how to manage an online class than a physical class. I'm really lazy to do physical classes because I want to wear something and I want to sit somewhere and do the classes. So it might be annoying. So I like online classes. While I'm sleeping, I can do the lesson very well, right? All right. So that's a different story. So I want to keep you awake actually. So that's why I'm asking. If you don't know, then that's fine. Who cares? I'm not killing you, right? Yes. Next one, Geet. And that's not to be shy to say I don't know. No one knows, right? Even I don't know whole the story. I know very limited, just less than 1% of the entire AI work. Probably less than 0.5. So there are a lot. So if you don't know, that's it. No, I don't know anything. That's it. Yes, Keith, sorry.
Yes, sir. Idea is a computer system uh, that works by human instruction. The special thing is they can adapt what human give, like the instruction. For example, if we give some images or some instruction, like something after in the second time, machine can adapt to that. And that's the
All
facility.
right, that's with a good example actually. Image classification, an existing interesting story, right? Interesting story. I will add something for you, Geet. We'll come to this point actually later on, but today we'll add something. I'm not sure whether you have this experience or not. I think you are using Facebook. Everyone, anyone without you don't have this experience, so you can't understand what I'm telling. There's the people who do have Facebook profiles and uploading different kind of selfies, team photos, family photos and stuff, they know the story that I'm telling, what I'm going to tell. A time back, once I've started the Facebook 2000, I can't remember, 2007, probably before that. I can't remember somehow. 2012 around, if I'm not mistaken, 12 or 15, 14 around. I can't remember the extract year. And up to that time, we posted some images. And 12 something, I can't remember actually, guys. The year after somehow after 2010. Uh, Once we uploaded a photo, it automatically detects our profile and name. We was wonder at that time, if I'm not mistaken, at that time I'm doing I'm an undergraduate. Oh, I'm a master student, I can't remember, somewhere like that. We was wonder, oh my god, we was uploaded a photo and a couple of friends are there. All of a sudden it detects the face and telling the names of us, right? It's something that we was wondered, right? We was wondered, we experimented, we uploaded a lot of people photos and check whether this Facebook can detects very well. At that time it's something that you experience nowadays in ChatGPT. I don't know whether you are experiencing happily ChatGPT or just using ChatGPT for the assessment completion for the sake, thanks god. මේ ChatGPT නැත්තම් මම ඉවරයි කියන level එකද මම දන්නේ නැහැ. Somehow if you are interested, if you are entertaining with these things, I'm pretty sure like, oh my god, it's a beautiful implementation. Even once I very first started the ChatGPT, I was wondered. I just asked many questions. It gives a lot of question answers to me. Even then I was thinking, what about Sinhala? I asked Sinhala law questions. It gives answers for those things according to these law, these things. I don't know whether you was focused on that kind of a experimental thing or not. For me, it's like very tasty experiment. Right. So image recognition, face recognition, image classification, all of these comes into this artificial intelligence, like machine learning. Right. So don't get upset with these words with machine learning, artificial intelligence, or computational intelligence. We'll discuss in high level. You apply whatever the correct word according to your answer script, but I'll just tell it's AI for the sake of easiness, right? Thanks, Geet. Good example. Time back, we have cats and dogs classification, apples and orange classification. Those are interesting classification problems, and probably you also do these things if you are really like to this subject. And in the other hand, nowadays we don't want to bother a lot because there are a lot of implemented codes. And in the other hand, if you ask the same question from ChatGPT, It generates the code for us and give it to us. Interesting, right? Interesting. So it gives every code, every single line with commented. So if you just ask sample k-means implementation for a test.csv file, and if you just copy paste the data in CSV file, then it generates everything for us. It detects all the column details and rows and everything. Then it develops the code for us and print it. So it's very powerful. It's a very powerful language model. Yeah, in a totally different world than 2022. Right? Somehow, I have another video for you, a small video clip, because I don't want to speak alone. We'll speak different people unless same tone might sleepy.
What is machine learning and how does one define machine learning? Machine learning is a data science technique used to extract patterns from data, allowing computers to identify related data, forecast future outcomes, behaviors, and trends. If that didn't make sense, let's actually break it down to see what that means. Next, let's understand how machine learning is different than traditional programming. In traditional programming, the inputs of hard-coded rules and data are used to arrive at the output of answers. You provide the traditional program with rules and data, and it gives you your results or answers. Whereas in machine learning, we take the data and answers as an input, and it returns the rules. For example, when determining whether...
Oh, sorry. I'm start stopping it.
What is machine learning and how does one define machine learning? Machine learning is a data science technique used to extract patterns from data, allowing computers to identify related data, forecast future outcomes, behaviors, and trends. If that didn't make sense, let's actually break it down to see what that means. Next, let's understand how machine learning is different than traditional programming. In traditional programming, the inputs of hard-coded rules and data are used to arrive at the output of answers. You provide the traditional program with rules and data, and it gives you your results or answers. Whereas in machine learning, we take the data and answers as an input, and it returns the rules.
Few times should be. Right. I think you can hear some tactics going background. So that's the difference. How the small annoying noise might comes from the background because a continuous tractor is running for half an hour. So we'll see what happens. I'll try to give my best. Now you can see
For example,
in here.
whether a flight will be
Right. You can see in here, we have rules and data. The traditional program, we have rules and data. So what they have done is what even we initially, we have rules as an example, if condition, looping, for loops, right? So all of these are used rules to run a program. To run a program. It's a very limited environment. It's a very limited environment. We know what happens whenever do something. As an example, a user inputs correct username and password. Then we know what is the output. In the other hand, we know something like if the user is doing something incorrectly, it gives some output, incorrect output. So these are very limited. We know the things, we know what happens with these rules. We define all of these rules very well because we know the output, limited output. You got it? For a username and password, it's very limited. For something else, it's very limited. For a programmer can do very limited things, and especially based on the data. Data in the sense, the username and the password. Your username and password is different than me, but the logic is exact same. we have thousands of millions of people, the same extract logic we can use for this authentication process. Username and password. Username and password. Same logic applies throughout. Got it? That's the traditional program, and the answer generates based on the username and password or whatever the rules and the data that we have. The data is checked by the rules or the conditions. Then, if something correct, it gives something correct. If it is something wrong, it gives something incorrect. But once it comes to machine learning, the story is different. What is difference means we have data and answers. Then we are asking machine to define rules. You got the story. We have data and we have answers. As an example, we'll take apple and orange classification problem. We have apple and orange classification problem. What happens in here? We have thousands of millions of apples. We have thousands of millions of oranges. We have thousands of millions of apples and oranges. Then what we are doing, we are taking different parameters or features in our context. Those are features. What are the features? Skin color, the color of an apple. There are a range of colors: red, green, some like kind of brownish red, right? Brownish red, large range. And oranges, we have a range of oranges, colors, and the skin design, whether it's silk smooth or very rough. Usually apples are very smooth, right? Oranges are much rough. So we can capture all of these things: size and the shape, size and the shape. We can collect all the sizes of apples, and we can collect the sizes of oranges, shapes of oranges and shapes of apples. What we have done, we have collected a lot of information of apples in detailed. In detail means with parameters or features. We collected feature wise. As an example, we'll take apple 1, then we collected apple 1 size, shape, and all the details. Apple 2 size, shape, and all the things. Apple 3 size, shape, and all the things. Then we named all of these things as apple. That means apples do have a big range of colors, big range of sizes, big range of shapes, and everything. What we have done is we have collected all the parameters. Those are the data, and answer is apple. Because we know the answer and the data and the answer both. You got it? We collected parameters. When then we have tell to the computer, hey, if you have anything that related to this kind of thing, this kind of data, what you need to do is you need to tell this is an apple. These are the features, the details of the features of this orange. Then what you need to do, if you found something in this range, you have to tell this is an orange. You define the rules as you want it. As one of your student, your friend told, it's statistical context also in here. Statistical context, how the data distributed. What are the means, medians, Q1, Q3, Q4, Q1, Q2, Q3, and changes, ranges, all things are there. How the data distributed, everything considered by the machine. That's why people are telling machine is learning. Actually, no, machine is not machine learning. It's learning based on the mathematics that we have in current world. We have math in the world, right? We have math in the world, stat in the world. Then we know how the if there's a distribution, how to find something. Then what machine is doing? Machine does the same thing. Machine takes different math algorithms, structs algorithms. Then it finalized something learned by the data. Learned by the data, then it defines rules, set of rules. Based on that rules, whenever something new, apple or an orange comes, then it can easily detect, okay, this is an apple or this is an orange. You got it what I'm telling? The traditional programming and machine learning is totally two different paths. For traditional programming, you don't want data. You don't want data too much. All you need to do is you need to create a database. You need to create how this first second normalization goes. All you need to do is how this data transferred from one place to another place, from user interface to the database, and how to extract from database to user interface, how to redirect one place to another place, those kinds of things. But that's why you can add some random users and random password and get some work done and demonstrate to your lecturer, right? That's how you got marks, right? You haven't collected thousands of people data and put into the system. You haven't done that. What you have done, you just created some logic, then you confirm to the in the demonstration, yeah, my logic is perfect. If username and password is correct, it redirect to the correct page. If the username and password is incorrect, you direct it to or give a message or a pop-up, it's incorrect. That's the whole story, right? That's the whole story that you have done. But now we are going for a paradigm change. Now we have to focus on data. That means without data machine learning, we can't do. I'm telling again this sentence. Without data, we can't do anything. We can't do anything else. Now think, you should be very wise, right? You should be very wise. If you are solving a problem without data, using machine learning, you can't do it. Or random data, you can't do it. Discussion pop-ups in many places to me. Can I use random data and develop a model? No, you can't. No point at all. Because the golden rule in our context is garbage in, garbage out. If you feed bad things, system feeds bad things for us. අර ඔයගොල්ලෝ ගිරාපෝත් එක දෙන ජාතක කතාව අහලා තියෙනව නේද ළමයි? අන්න ඒ වගේ තමයි. එතකොට වැරදි දේවල් ෆීඩ් කරොත් වැරදි දේවල්මයි අවුට්පුට් වෙන්නේ. හොඳ දේවල් ෆීඩ් කරොත් හොඳ දේවල් ඉන්පුට් වෙනවා, අවුට්පුට් වෙනවා. Clear? So that's the whole story. If we train machine the good things, machine will give the correct answers for us. If you have trained incorrect things, the machine would states incorrect things for us. Got it? That's the whole story that you need to understand. So you can't do random data, you can't generate your data, you can't manually interpret the data, then we can't create a model. So once it comes to this machine learning, there is a problem. Yes, good. You can have any problem, that's fine. Problem is not a matter at all. Next thing is collecting data, which is the hardest part for us, especially in our context, like Sri Lankan context. Barnese people don't like to give data, especially the businesses. They don't like to give the data. Then they have to pay more taxes. That's the core reason behind that. Somehow they don't like. Somehow they don't like to give data. The second thing, we are really lazy to collect data. Think if someone asks, can you spend 1 month to collect data? Oh, really? Mata maasaka nada data collect karana. Then no point at all. I don't know. Isn't it? We are really lazy. We are really lazy. I will share an experience with you. Not my experience, one of my friends' experience. You know, once it comes to this Google Maps, in Sri Lanka, there was a big set of people, probably more than 500 people, was marked humans in road. But the job is that they have to do is they have paid actually, not well, but average level they paid. What they need to do is there is an image. You need to classify, you need to draw if there's a human, the outline of the human. In Sri Lanka, it was happened. Some of the things was happening in India, some of the things was happening in Sri Lanka. The human classification, human identification happened in Sri Lanka. You don't know why? The Google Maps, the entire world, no, sorry, South Asia region. South Asia region, Sri Lankans was classified a human. What they have to do is they have to draw an outline of a human. Normal human, that's not a problem. It's just very easy because the shape is. But some of people like take hands up. Some of like in with different accent. So at that time, it's like quite hard to detect. So these things are the outliers. We'll come to these outliers, different kind of implementations. I'm telling all of these words today because your brain should understand whatever this. Once I'm doing same thing again and again, right, you will get used to it. Those are outliers. Some different, like black sheep, the person who is different than the normal. In Sri Lankans, everyone is around 5 to 5.5, 4.5 to 5.5 in height. අඩි 4මාරක් 5මාරක් වගේ උස තියෙන සාමාන්‍ය. But very rarely we can find people who have 6.5, 6.3 like kind of people. Very rare, eh? It's very rare. Outlier. It's an outlier. The skin color, it's different. Hair color, I can't tell because people kill, so I can't give the answer. Somehow interesting, right? So what you need to understand is if you are focusing on solving a machine learning problem, what you need to do is you need to collect sufficient data. Sufficient data means you need to collect thousands of data for statistical implementations, statistical things. It's more than enough for 100 to 1000 data. It's a sample of data. Then they, based on this sample, they do something. Yeah, agree. Good job. Appreciate. But actually, it's much more than work that we want. What we want much more. That means we want thousands of millions of data. Then only we can do something properly. If we have 100 data set, you can't do anything, guys. Guaranteed. But you can do up to some extent, but it's not a proper model because your data set is very limited. The features of the data is very limited. I will give an example. You collected 100 red apples and 100 oranges. 100. Then you have developed a classification algorithm. Then the first ever testing is for a green apple. Then the entire model is get confused. Sit it. Sleeping. No. All good. Right. I have a guinea pig today for testing purposes, for everything, fortunately. Right. So it's like we have to collect apples in a range of apples, a range of people. If you are testing for something, we want to range starting from the ending from the we don't know. If you have billions of data, then your model will be very strong, like ChatGPT. They have billions of data. That's why they can do many things. For us, for our experiments, we are focusing on 1,000 data points, 10,000, probably 50,000, not a million. If you have millions of billions of data, then it's a perfect solution. Very nice. Got it? Clear? Any questions up to now, guys? Anyone? Ask any question. Any question in the sense related to the subject. Yes, language models. All of those are natural language processing. Others? All good. All right. Then I will give a question to you. Sorry. We'll continue this one and we'll see.
For how to use that data. For example, if there is extreme weather, generating the answer that flight is likely. One of the limitations of traditional programming is that we might not always come up with the best rules. So this is where machine learning comes in. In machine learning, we have historical data and the answers, so the flight is delayed or not. And we let the algorithm explore the relationship between the data and answers to come up with the rules. Maybe departure time has an impact on flight delays. So the power of machine learning is that it can use historical data and generate rules that we might not have thought about. It is very typical to write high-performing traditional programs for applications such as fraud detection, object detection, speech recognition, recommendation engines, and the list goes on. Machine learning allows computers to learn automatically based on observation or data. Machine learning is best suited for applications in pattern recognition, anomaly detection, time series forecasting, and recommendation systems.
Right. Then my question. What is this? It's a mop. It's a mop, right? Anyone do not agree with me?
It's a dog.
It's a dog. How comes it's a dog? Who is that? Beautiful fellow. Sorry, who is that? I still I can't remember the names. Yeah. Callum, right? Good. Callum, how comes it's a dog? I can't see anything related to a dog. I can't see a tail. I can't see ears. I can't see anything, eyes or anything. How you I understood it's a dog, a superhero?
I have seen this kind of video before. AI related.
Sorry, sorry.
I have seen these kind of videos before.
You have seen these kinds of videos.
Yeah.
It's very interesting. Any others? Any others seen this kind of a video or an image or something? Actually, good. Good. You have some previous knowledge. That's sort of for a human. Even I can't see it's a dog. Actually, it's really annoying, right? How comes it's a dog? But machines can classify these dogs very well than a human. This is actually a dog. It's a small PNG file. It's not running here because I have run two things. I'm running parallelly two screens. So this dog is not standing up now. I'm sorry, guys. I need to go for a single screen for this one. If it is a single screen, I can't do anything. Right. So you just search in Google dog cursor map, then you can get this example. This is a dog. For human, we can't recognize because humans, as human, we have that's the reason. That's the first reason is we don't have experience. We have in Sri Lanka we can't see this kind of dogs. Lot of dogs we can't see. But in rich countries they have these kinds of nice puppies, dogs. Now what happens in here? The machine we trained, not myself, the people who develop these kinds of things, they trained. They took thousands of dogs, thousands of and millions of dogs, and feed it to the machine. Then machine knows, okay, this is this kind of a dog with this kind of breed. Got it? That's the whole story. That's the point that we should focus on a human and a humanize a very, very what we call very poor to identify these kinds of images because we haven't seen. Actually, the first time that I have seen, I was like wonder. I thought it's just some of rug. I was thought it's a rug, collected rug in somewhere. I wasn't able to identify. I don't know whether anyone can identify. Like, if you seen a dog this kind of, then you can. But for my life, I haven't seen this kind of a live dog, not video dogs. A live dogs I haven't seen naturally actually. So my eyes was, my brain was very what we call very poor to identify this kind of thing. But machines, they can, because the people who develop these components, they spend thousands, millions of hours and thousands, like parallelly. They collect a lot of data, they process all of these information, then they identify this as a dog. That's the point. A human is to have very limited skill. We have very limited. If I ask a simple question, 2 days back, what's your dinner? I can't remember, sir. Yesterday dinner. Give me a few seconds. I want to think. I'm correct, right? I'm correct. So the human is that's the story of a human brain. We neglect everything. We can't remember anything. Even like if you ask 1 year back, like same day today, what do you have it? I shows it's something annoying, right? I can't think even like what has happened. But if I ask this kind of a question, can you remember whenever you went for a hotel, you ate something, right? You can remember all the things and the how you spent the hours and hours in there, walked here and there, what you collected, ate, the taste and everything, right? It was years back, right? I don't know, think years back you went for any hotel. You can remember everything, isn't it? But you can't remember 2 days back. The difference is the brain cells are very powerful, but we don't use it. Once we are eating, we just eat it for the sake of hungry. That's it, not for a fun. But that hotel, it's totally different. We can remember all the things, all the things, all the things we can remember. If we keep memorizing all the things once we are working, our brain cells might full of within 24 hours. 1,000 people walked in every place. 1,000 people. We can't remember. There are some people, ultra super people. There is a movie, um, the first ever, what we call this. It's a real story. The vice president of Bangladesh, if I'm not mistaken. This is a Hindi movie. Uh, then the interview is kind of an interview. Uh, the same car is traveling twice. Then the interviewer is asking, "Do you have seen something?" Yeah, the person is telling, "Yeah, the car number, the specific car is uh, followed us twice." There are specific people, not us, right? There are some specific people. That's why he's a vice president. We are not a vice president at all, right? So that's the whole story. Some of people do have these ultra super skills like photography, photonic skill or something. I can't remember. Some name is in there. Like they can capture image wise, then they can save, but not for us. We have different people in the world. Some of math specialized, some of art specialized, drawings very nice. Some of people are dancing very well. Some of music is very well. මම මෙතන මොන හරි නටන්න ගියොත් මම සින්දුවක් කියන්න ගියොත් ආයේ ඉවරයි, right? None of you. And my drawings ultra super drawings, writing ultra super. No one can read, only myself. We are different, but some of you might be a very good singer. Any singers? No. All right, somehow that's fine. Now that's something that's why I want to differentiate a human brain and a computer. A computer would focus on a specific thing. If we give thousands of millions of dogs, it just creates a set of rules for these thousands of millions of dogs and cats, or whatever the things that we are feeding. That's it. But for a human brain, we have 5 sensors, so we push all the information all of a sudden for our brain. So it's very limited and can grab very limited things. You can't memorize, but computer can do a lot. Terabytes stored as it is, persistent. It's not changing. Two components in here, right? We'll do a small work. applications of machine learning. What my suggestion is, create a Google Doc or Office 365 document, not a Word document, or else Word document in your machine. It should be a online document, sorry, or else you can use a book. You can use a book. Why I'm telling not your machine, you will write something in your machine. Next day, you can't find where is it. You have to spend hours and hours, hours and hours. Where is my Word document? But if it's Office 365, if you give a specific name, or else if you just use Google Doc, more specifically, Google Doc is much easy because every time you are using, you just go from Google Docs, then that document might stay forever. So the best thing is create a Google Doc and write what you have learned up to now, and write applications of machine learning. I will give around 10 to 15 minutes. Uh, you can share the URL with me. Meanwhile, I will create a Telegram group because that's the much simplest method. I'm not using a WhatsApp. I'm using WhatsApp, but I'm not giving my WhatsApp to my students because you might misuse, like you might share your personal things with me. I have a lot of experience, like the students do have what we call WhatsApp groups, right? So what happens in there, they just copy paste something like time back once an online class. මේක සර්ට නම් කියන්න එපා කියලත් මගේ chat එකේ දාලා තියෙනවා. Right, so that kind of annoying thing I don't want to happen again for a student, right? You know, there are something private for the students, they don't share with the lecturer, right? They have some different kinds of things there. So you just use WhatsApp groups. So Telegram, දැන් එතකොට දන්නවනේ මට තමයි මේක තියෙන්නේ කියලා. එතකොට then you are in a safe stage every time. You don't want to get into trouble. Clear? I will create a Telegram group. Give me time. Within while you are writing, I will share this group. You can take around 10 to 15 minutes. Write whatever you learn up to now. An introduction in that document. Whatever you learn, examples and stuff. Not lengthy. Don't use ChatGPT and copy paste in there. No point at all, right? You just write what you learn. Even if it's 2 lines, I'm happy. In your terms. And sample applications of machine learning. All right. You can take around 10 to 15 minutes. Right. I believe I have given sufficient time, more than 15 minutes. How about the progress? If you don't mind, could you please share your links in the chat? And further, I have created a Telegram group for easy communication.
I now writing the books.
Sorry.
I writing the books. This note and
You written in a book. So what you
yes,
can do is take pictures and paste it
in,
in a Google Doc.
okay,
Huh?
okay.
That's good. Please keep it public unless I am unable to access. I need to uh, go through a login process. I need to request your approval. So keep it public. Don't worry, I'm not sharing with anyone. Right. So still I haven't received. I just link can't access public. Go to right hand side corner. There is to change the settings to public. Oh, anyone with link probably. I can't remember the name. But, so you can continue the work and you can take a small break around 10 to 15 minutes. Uh, so 11:5 we'll start the rest of the discussion, uh, starting with the data science and the data science process. So you can take a small break, go outside, have a cup of tea, and come again.
Excuse me, sir. Sir,
Yeah, please.
sir, chat is not there. Can please
You
the tell
can't.
send me to the documents, sir.
Chat is not visible means you are in. You are as a guest. So you have
Um,
logged in from the ICMT email.
no, sir. I my personal account.
That might be the reason. You need to add access through this ICBT mail, or else you send me an
I
email. Then I can share it in the what we call this. You can send me an email. Then I will share the link in that email.
okay, sir.
My email address is. I will type it. It's here. And you don't have my personal details, right?
Yes, sir.
Yeah, I'll share. Share my. You can see my information. Oh, shit. Gone.
No, sir. It's empty folder. It's capital or simple,
Sorry?
capital or simple,
That's
simple
my.
letter.
It's a simple, simple. It should be
Yes,
simple.
okay, okay, sir.
Sorry?
Okay, okay, sir.
Oh, All right, I think everyone is back to the seat, so we'll continue this discussion. I believe you have written something and it's in your machine or somewhere that accessible by yourself. So we'll continue to this discussion a bit more. So some of applications, it's very detailed and very lot of information in there. We'll see some of sample situations.
Applications of machine learning are quite broad and diverse. For all these applications, there are several techniques that are frequently used that include statistical machine learning, deep learning, and reinforcement learning.
So these are kind of
ML is very useful with
algorithms,
natural
right?
language
Machine
processing
learning, deep learning,
applications dealing with
enforcement.
text and speech. Natural language processing is often referred to as NLP. For example, NLP can be used to summarize text, power search, automatically detect topics, and identify if any two texts are similar. With regards to speech, NLP powers applications like speech to text, which converts recorded human speech to text, or the opposite direction, that converts text to spoken audio, or even the translation of speech from one language to another. ML can also power computer vision applications,
So
including
these are different kinds of
self-driving cars,
applications,
describing
guys.
the contents of an image. This
So
is referred
natural
to as
language
object
processing,
detection,
computer vision.
locating specific objects within an image, object identification. Computer vision can do this with image created both in visible spectrum that you and I can see, as well as other image types like LIDAR images that are collected via laser scanners. ML can power analytic applications that help us make predictions performing tasks like regression, classification, forecasting, and clustering. ML is also useful for powering decision-making applications. Whether these
So
are
these are
sequential
analytical and
decision-making
decision
problems
making,
like
which is
playing a
very
video
important
game
in
or
our
optimizing
case.
content
Mostly
recommendations based on
our
user
work
interaction.
comes to here,
When you come
analytical and
across
decision
new
making.
applications of ML, take time to consider which of these four quadrants the application might fit into. It will help you more quickly get an understanding of the type of machine learning at play. Machine learning opportunities cut across industry verticals, irrespective if the industry is healthcare, finance, manufacturing, retail, and significant. A few applications of machine learning are listed here. So for the first example, let's look at automating the recognition of disease.
A lot of disease recognition, skin diseases, and many other applications are there.
The
Recognition these
capabilities of
diseases.
machine learning extend the reach of human physicians beyond those who can make an office visit, and to enable evaluation of higher volume of patient data than possible by the physician alone. The next example is recommend next best actions for individual care plans. Reaching an accurate diagnosis can sometimes be a challenge, even for the most skilled providers. However, the mass digitalization of patient data via EMR and EHR system opens the door for machine learning to help augment the diagnostic process to build effective individual
These
care
are
plans.
these are
Through
recommendations again.
analysis of the patient's digital health
We can do
footprint,
the same
such
thing
as lab
again,
results,
guys.
history, and reported symptoms, advanced analytic tools can surface potential diagnosis and recommend the next best action for care. The next thing we're going to consider is enabling personalized real-time banking experiences with chatbots. Bots and intelligent assistants are natural solutions for the first wave of customer contact. Much like how interactive voice response, IVR, transforms inbound service calls, machine learning can intercept and handle common, straightforward issues with chat and messaging services. So customers can quickly and independently resolve
So
simple
in
issues
like
that would
reasoning and
otherwise require
arguments and the
human
reasoning. This is
With a
the story
chatbot, a
that
customer can simply
comes
type
to
in a
here.
question and the bot engages to surface the answer. The next example we're going to look at is identifying the next best action for the customer. Solutions for real-time insights incorporate machine learning tools such as sentiment analysis to help organizations assess the likelihood of a deal closing or the level of a customer's loyalty. Personally tailored encounters powered by machine learning can engage and delight customers with information and offers that are relevant to them. Additionally, employees can generate cross-sell and upsell opportunities with a higher likelihood of acceptance, resulting in increased wallet share. The next example is capture, prioritize, and route service requests to the correct employee to improve response time. A busy government organization gets innumerable service requests on an annual basis. The ability to address such a volume of requests while maintaining high service levels can often be a strain on operation resources. Machine learning tools can help automate this process by capturing incoming service requests and routing them to the correct employee in real time. Machine learning can further impact service levels by adapting over time to surface insight around the speed to closure for specific types of requests, thus refining prioritization and improving response times.
All right, so a lot of industries and industry vectors and different kinds of implementations that they have discussed a lot. So basically, they was focused on natural language processing, image processing, and different industry vectors or the business vectors. Like we have focused on what we call this image based disease recognition. So these are very powerful vectors in industry level. So what happens in here, they use these algorithms and they use all of this stuff to clarify or identify all of these issues, different kinds of implementations, and many other things. Right? Guys, can you see my screen? Online students? No. Check now. Okay, all right. So we'll go to right. So these are some of vectors that we was focused on. Let's go to the next one. And examples that we have learned up to now. Apples versus oranges, classification problem. We have thousands of millions of apples, then we extracted thousands of millions of sorry, we have extracted number of features. It's black. Okay. No. Well, what about now?
I think it's my problem.
Dasun, Callum,
Yes, sir.
how about can you screen?
Yes, sir.
Can see. Can see. Right. So it's basically a classification problem. These kind of problems are known as classification problem. We have to collect features, red color, the shape, and different specific features, right? All of these things, how it stays in a specific place and stuff. And we can classify, we can identify the same thing, the skin rough or not. Silk smoothness is not smooth at all. The color is different than this one, and we don't have this kind of specific feature, but we have some additional features that we need to identify. So these are very important to AI application development to identify, the recognize all of these features. Based on these features, we have thousands of apples, we have thousands of oranges. Then what we have done is we collected all the information and given this is an apple, this is an orange to the computer. Computer learned from these information. Learning means there are algorithms, statistical and mathematical algorithms, which was used to get a work done, to identify different kinds of things. Based on that, if there's a new apple is given to the machine, computer is telling, all right, I found it very well. Oh, I understood this is an orange kind of thing. Furthermore, if we go for the same discussion, the face recognition, this is another very important point. Based on different features, we have specific features, nose, eyes, right? We have mouth, chin, cheeks, ears. All of these help to decide this is a human face. So why? Because everyone do have these features, right? Eyes, yes, of course. Mouth, yes, of course. Nose, yes, of course. So for a computer, what it does is it identify, okay, this image do have eyes, this image do have eyes, and plus nose, plus mouth, plus plus, all of these features are plus. Based on these additions, it identifies, recognize this is a human face. It's easy. This is a common situation. We all do have common situation. Thousands of millions of faces do have common things, but we have some uncommon faces. It's weird. Recognition is bit hard for this kind of a thing. As a human, we can understand, yeah, of course, but for a computer, it's a bit hard. See, the image is totally distorted, and sometimes it might be an edited image, but this is a human image. Clear? This is not something some any other animal. This is a human. Recognition of this human is bit hard for a computer because computer decides all of these features, ears, mouths, and stuff. But for this image, it's not. That's why I'm always telling we have to give a range of uh, information, range of data, range of features to identify this is a human or not. For this circumstance, if we given the good faces only as an example, normal people's faces, then computer would get stuck this kind of a situation. Now, if now you know this the specific technical term, this kind of image. What is this? This is an outlier, something abnormal. This is not a, these are general images, common things, but this is something abnormal, which is an outlier. We are not expecting a human face like this, but there are. But there are. These are the general faces, common situation. These are the common situation. This is something uncommon, but computer would, it's a must to understand. So this is an outlier, some different case, but very rare. This is very common. It's very common. It's very common. So the computer would be able to develop the required all the rules and the suggestions, then blah 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 things, and give a prediction or classification or any other thing for a normal face. That's fine. It's much easier. But there are some outliers like this. Still, your application should focus on these kinds of outliers and identify all of these outliers too. More specifically, like industries like what we call medical industry, very limited. We have thousands of millions of normal people, but these kinds of faces very limited. So to train an application, to develop an application using these kinds of things is bit weird and bit hard, and the effort that you need to go through is very hard. You got it? So these are outliers. Not only outliers, some of ranges of things. Now, all of these are apples, but at a glance you should be able to identify a couple of things, some of modifications to have done. What has happened? One is a green apple. This is an apple again, but it's green. These three are upside down, isn't it? These are upside down. Sorry, these two are upside down. This is the normal image that we are focused on, normal general image. Computer still would be able to understand, all right, it's upside down. It's an apple. All four are apples. One is a green apple. These are upside down. This is not an outlier. Don't misunderstand. In this situation, it's an outlier, which is out of so abnormal situation, something that weird. I'm telling not the face, right? I'm telling the situation. These are the normal phases, and this is something abnormal phase, something different. And like 90 to 95 percentage is general phases. There are five or something that like this kind of outliers, abnormal situation. But this is not. This is a common situation, but it's in a different angle. The same thing in a different angle. So computer would able to go through, the algorithm should be able to go through all of these things and understand what happens in each and every place. This is not something easy again. That's why I'm always telling we have to have thousands of millions of data points to get a proper work done. If not, what happens? They said there might be a big mistake that we all are doing. So we need to feed correct data. We need to feed the perfect data as much as we can. Whether it's upside down or it's in a different color or different angle. Sometimes it might be a half away eaten apple. There are possibilities. All you need to do is all you need to understand very well. There are a range of things can be applicable in our context. Software engineering don't have this kind of painful situation, because if we written a username and a password, a logic for username and password, obviously that's the whole story. Even if we have thousands of millions of people logged in, then we can let or write you add your username and your password. That's it. It's much easier. But in this situation, it's not, because it starts with data. Artificial intelligence starts with data. If we have sufficient data, then only we can create models, artificial intelligent models. I'll discuss these models, algorithms, and blah 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 things time to time again to get much familiar for you, because these buzzwords are a bit new for you. I'm pretty sure I know the story. It's obvious, something new for you, but all you need to do is you need to get familiar with all of these things. Now, since it starts with the data, we should understand some of the aspects related to the data science. This course is not focused on data science, but without data science, you can't do anything, because data science practices from the collecting to data to processing the data, pre-processing, everything is a must before you go for an AI application, or if you are going for an AI component, right? So it's a must. So you should understand, you should go through all of these things very well before you are going through the next steps in AI model development. So I will give a small introduction to the data science, but if you want to go more detailed, I'm really happy to see you in much more detailed context. Right. Data science is a buzzword, as you already know. Everyone speaks. What is this data science? Artificial intelligence. Many things that you are speaking in day-to-day life. What happens in here and there, and how it goes, and many things that you are going learning and understanding, because it's a buzzword, and it's very important and very easy to understand what is this data science. But well, detailed data science is a bit complex than a normal situation. The examples that I have given is much related to algorithm usage of an algorithmic implementation. But once it comes to data science, you have to start with raw data. That means nothing. So why all of a sudden data science comes into the context? The very first thing is data availability. We have sufficient data, where IoT systems generates data, even computer systems generates thousands of millions of data. As an example, if you go for Facebook, we have we are creating thousands of data points every time. Whenever you are scrolling, whenever you are adding a comment, whenever you are like, whenever you do sharing, all of these contexts, what you are doing, you are generating new data to a system. Simply you are logged into a system means, then onwards what they are doing, they are tracking your behavior, what you are doing, what you do, whether you click it or not, whether you move to the next page or not. If there's a crash, then they are telling, all right, once you are doing this kind of thing, you got crash, isn't it? And browser information. Lot of things are there. We have now sufficient data, so the data availability is not a matter at all. But many cases in Sri Lankan context, we don't have data. If we start to do something, we don't have data. Why? We haven't recorded the data because we are practiced to do something randomly, or just we have to do focus on. අර අපි කියන්නේ එදාට වැඩේ කරගන්න අර ගොඩ දාගන්න විතරක් වැඩේ කරගන්න. So we don't have data, so we can't do many things. That's the issue in one aspect, data availability in Sri Lankan context. But if we have data, we can do a lot, and data science world starts with the data availability. We should have, it's a must. Without data we can't do anything. As an example, a lot of places I am getting requests to develop machine learning algorithms and many things. My very first question is from the client side, I'm asking how about the data availability? Do you have sufficient data? At that time some of business people are telling not yet, we don't have any data. Some of people are telling, yeah, we have some manual records. And some of people are telling, yeah, we have some databases, but not full. It's just partial. So the story is bit hard. If you don't have data, then you can't develop. Then they might find a person who can develop a model cheaper for the cheaper price, and that model is not working, so they are getting lost because they don't know, the business people don't know the story behind it. So now, since you are a student, you should understand very well, don't go for anything if you don't have data. It's a must. Data is must. You should have thousands of millions of data is must, especially once it comes to real world application development. Data is must. You can't randomly create. These are very common things the business people asking, මට එක data ටිකක් දාලා sample data ටිකක් දාලා ගන්න බැරිද? No. Tell no. Directly say no, I can't. To do that, you should have real world data. It should be clear data set. That means like a flow should be there. If you have random data set, as an example, you have data sets like 1 to 3rd, then all of a sudden 7 to 8th, then 9th, then all of a sudden you have 15th of month, right? Then 25th of month, then 28th of month. That's it. You can't create a model. You can't do anything for these kinds of random data. These are random data. It's not a proper flow. At least it should be in a proper flow, and you should have sufficient data to do anything. If you don't have sufficient data, you can't do anything, guys. That's the reality. First thing. Nowadays, since we have a lot of data science comes into the context. The second point is computational power. It's not a big deal. I'm pretty sure you have sufficient machines to train your models, develop your models and stuff. In our context, I'm just talking about the data science. Why the data science comes into the context? Because computational power is very higher than compared to the last few decades. We have sufficient data, a lot of data. Yes, we want to process it. The second point is we want to process it. To process the data, it's a must, computational power. Some of people are telling, I have spent 2 days for a neural network. Sometimes it might be true, sometimes it might be false. Some of people are telling because they are telling like for false information. So the computational power nowadays is very high. Data is available, and we have very sophisticated environment to do. Next, what you need to understand is newly implemented algorithms. We should have, there are a lot of algorithms at the moment developing. At the moment it's developing. Plus last couple of years, a lot of new algorithms was introduced. Complex algorithms, very complex algorithms. Based on these complex algorithms, then they have focused on these things. mainly companies are focused on data driven decisions. Now, time back, organizations was focused on higher space paid person's opinion, in simple terms, HIPPO's opinion, higher space person's opinion. But nowadays, most of the organizations are taking decisions based on the data, based on uh, the insights are based on the data. So you should be understand very well. Without data, we can't go for data driven decision. I will give an example. Now I have a model. I have a lot of data related to the students who are doing these kinds of subjects like data science and artificial intelligence plus some of these things. I have very nice computational power, and I have nice algorithm in my head. It's implemented in my head, not in a machine. Based on those algorithms and based on data, I can predict. Right? I can predict after week 3, there might be 1 or 2 students maximum in the class. Even they join around 9:15 around. So these are predictions based on the previous data. But believe me, guys, one of golden rules in data science is and artificial intelligence is past is not the future. Past is not the future. Past gives insight for us, but it's not the future. Future might be different, but sometimes it might be not a lot. Sometimes it might be some of up to some extent. So now you know why this data science comes into the context. What is data science? And we'll discuss again what is data science a bit more. Why data science comes into the context? Because we have data, we have computational power, and organizations are focused on these data driven decisions. Now, what is data science? The question is should be start from here, right? What is data science? Data science is a very powerful story. So we have a lot of definitions. So what I'm going to do is I'm going to summarize the key points related to this data science. One is key point is collection of data sets. There might be different definitions. So one is collection of data sets. Whenever a definition, what we are focusing on a data science, it starts with a collection of data sets. What is data set? Data set is a collection of data. That's it. Simply an Excel sheet. Whatever the data that you have inserted into an Excel sheet, yeah, that's a simple data set. Well, that's good, right? Understood. Focused on many aspects such as data cleansing, data wrangling, lot of parts are there. Now, the data science is not just play with the raw data. Raw data means just the extracted data. Once it comes to data extraction, that data is known as raw data. Raw data is dirty. That means it's not processed, it's not clean. So we need to clean it. We need to process before we process it. We need to clean it very well. Cleansing, pre-processing, many things that we need to do if we go for a proper application in data science. A life cycle to get more clear data. That means whenever we extracted raw data, we have to focus on different steps. I'm going to discuss these steps in future in like within couple of minutes. Now, in general, data science means we have set of data, we have set of procedures to handle this data, raw data, and our objective is clean all of these data for model development. What kind of model development? Artificial intelligence model development. That's the story. Now, if we take partition into these two, basically what this is my partition is, this is not a standard definition, but this is generally covers the knowledge for an undergraduate. Data science extracted the data, clean it, and doing all the things that we want to do. Then it gives for us, for the AI people, artificial intelligent model development. If you are developing a raw if you are developing a model using raw data, that means without preprocessed, without cleaned, your model will be a worst product that you develop to the world. Because whenever we extracted data, we want to clean it, we want to pre-process it, we want to do XYZ, lot of things. Then only we have to start the AI models. So sometimes you might have billion of or 2 billion of raw data. Sometimes after clean the data, it might be just 50,000 of record. There is a possibility. So you should understand raw data means sometimes there might be missing data. As an example, age. Some of people don't like to give the date, the age. So it's empty. As an example, if we take we'll take Excel sheet. I'm pretty sure everyone knows what is an Excel sheet. I'm not going to discuss this CSVs and other stuff. Just think this is an Excel sheet. So this is the age column. This is the age column. So one person 37, 55, 59, 20, 21, and all of a sudden empty. This person do not like to give the age data. There are possibilities. There are possibilities. So you need to handle all of these data. And one person entered as 200, age as 200. Is that possible, guys? No, it's impossible. Impossible. After cleaning, sometimes think this is a 1 million or 2 millions of records. After cleaning, sometimes it might be just 50,000 of records in this clean data or the processed data. Got it? So the process of this data science and artificial intelligence is like it's a must. Without data science, you can't go for AI. In the other hand, AI always required data science, and always AI is giving help us to purifying and doing a lot of things for us in future. Identifying outliers, all of these comes into the data science context. That means like 80% of work should do by these data scientists. They need to start with pre-processing, and they want to provide very clean data to AI engineer. AI engineer's job is take all clean data, then based on that data, create a proper model that we can use. Understood? So that's the point of this data science and artificial intelligence. And well, a bit more about this data science and advanced techniques are there, like big data, data mining. Big data means we are going to discuss. We have high velocity of high volume of high variety of data. And in the other hand, we have much more sophisticated mechanisms for data mining. I mean, extracting data, finding patterns of data, and many other things. All of these are categorized into data mining. Understood? So I believe you got what is in very high level. If someone asks what is data science is based on the data, collected data, and focus on cleaning and purifying and ready the data for AI application development. Once it comes to the AI application development, what they are doing is they are using these data sets and data for model development, AI model development. That should be in your head now. In the other hand, once it comes to these data science approaches or techniques and procedures and many other things, we have, it's not just extraction to cleaning, we have some additional or advanced features like data mining, big data processing, data engineering, lot of aspects are there. So you should understand very well what happens in here and there. Okay? That's the story of data science. Any questions, guys? All right. Now, to perform well on data science, you need major three things: domain knowledge, programming skills, and math or stats. Now, since you are not focusing on developing any data science work, I want to remove this one. All you need to do is you need to apply these apply concepts to existing algorithms. So you don't want to develop anything. Hence, you don't want to bother on these maths and stats very well. So you are in a safe stage. Domain knowledge, you are not expecting a lot. You're not expecting a lot because you're not an industry person. So you don't want to bother a lot. But having a good knowledge of industry or the domain that you're focusing on, what are these industries? As an example, tourism, education, marketing, finance, stock markets, travel, transportation, beauty culture, fashion design. All of these are different kinds of business vectors. Now, if you have good, if you are like you are expert, I mean, not fully expert is up to some extent. If you are expert, then you are in a safe stage, because if something weird happened, if some weird information in that sorry, if some weird data in that data set, you could keep your eye on this data, because you know the domain. As an example, think for a subject, uh, all the students are getting A plus. Something weird. Sometimes, if you don't have any experience in education, you might say, yeah, there's a possibility. But if there's all A pluses and A's, that means something gone wrong. Can't. There is a bell curve where the students are usually stands. Very low number of students in very low age, very low number of students in very high age. Vast majority in between this, credits, passes, and stuff. Distinctions and above, it's less, and failures are less. General, this is the general term. These people are outstanding. These people are outstanding. They have done an extremely nice job. They have spent hours, they sacrifice lot, they burned a lot of night lamp. These people full of fun, they don't like the subject, poor, weak in that subject. But I'm not interpreting you are poor in data science and artificial intelligence means you are poor in music. That's a totally different story, right? Sometimes you might be an expertise in music, but you are not an expertise in data science. That's okay, because we are human. Yeah, right. That's the story of this domain knowledge. You should have good domain knowledge. What happens in this business vector? Oh, these values are feasible or possible or not? Those kinds of decisions making. For an organization, usually we have directors or SPOCs. SPOC means single point of contact. These people do have very good domain knowledge. In any case, we are calling to these people, then these people are fixing whatever it is. Then we have SMEs, subject matter expertise. Those are not in a technical context, but they are very well in business context. What happens in business world? Subject matter expertise. As an example, think a businessman don't have any knowledge in business, zero business knowledge, but they are doing very well nice business. They are but they are doing very well because they have inbuilt skill. They're subject matter experts. They know what happens tomorrow. Right? For your case, I don't think so. You want very well domain knowledge, but having a good knowledge is very important to take decisions. This is very important. Programming skills. You should be not an expert is, yeah, well, but at least up to 50 to 70 percentage of knowledge in programming is really important to develop a proper model, because you want to start it from somewhere, you want to end it from with somewhere. So the raw data to a model is a big process. So you need to understand this painful situation very well. By using data science, organizations would improve decision making, providing predictions, and many other models. We should understand it very well. We should focus on the decision making. We should focus on different kinds of predictions, and organizations are getting very good experience. Sometimes, as an example, you can apply process mining for zero number of counts, queues. People are in the queue, no, zero. Every time what happens, it's automatically working. Number of people are just started queue, already zero, because we have use the process mining techniques to identify the bottlenecks. Yeah, the processes are getting stuck. And in the other hand, some of people, I just told the same thing for business, one of business person. Why don't you keep zero queue? The answer was no need. We need a queue to show that people are coming to the business, to show there are vehicles in my land. They want, because people join to the popular places. Yeah, in other context, yeah, agreed. Right? If there's no human in any time, if there's no human in any time, people believe there is no business properly going on. Agreed, because he is a subject matter expert is in one domain. He's expecting a queue, not a big queue, but a sufficient queue. Yeah, agreed. But for an ATM kind of thing, I don't think so. We should have a queue. I believe it's zero. ATM kind of thing. If it is standing in a queue for ATM is a painful experience, right? We have given our money for their business to improve their business. They took a lot of profit from us, and they keep ourselves in a queue. It's not something good, isn't it? Right, somehow that's a story to decide by yourself. Well, those things are the some of organizational level things that happens in here and there. Any questions up to now, guys? All good? Sleepy? No? All right. Any others? Dasul? Kalum?
No, sir.
Kalum?
No, sir.
All right then. Then we'll watch a small movie. This is from another online material that I found.
My name is Liz. In this course,
Don't think about these
what,
names
why,
and
and
stuff.
how data science. By the end of this course, you'll have a better grasp of how data is being used around you and how you can use data. If we Google what is data science, we'll see a huge amount of confusing information. But data science is actually simple. It's a set of methodologies for taking in thousands of forms of data that are available to us today and using them to draw meaningful conclusions. Data is being collected all around us. Every like, click, email, credit card swipe, or tweet is a new piece of data that can be used to better describe the present or predict the future. So what can data do? Data can describe our current state, like our energy consumption. This can be accomplished with dashboards or alerts, simplifying time-intensive reporting processes. It can help detect anomalous events, such as fraudulent purchases. If we have data on what has happened previously, we can increase efficiency by automatically detecting a new event that is unexpected or abnormal. Data can also diagnose the causes of observed events and behaviors. For
for instance, your activity on Spotify or Netflix. Rather than determining correlations between small numbers of events, data science techniques help us understand complex systems with many possible causes. Finally, data can predict future events, such as forecasting population size. We can use techniques to take various causes into account and predict potential outcomes. Further, we can evaluate the probability of our prediction mathematically to clarify our level of uncertainty. So now we know what data science is. The next question is, why is it so popular? The answer is pretty obvious. We're collecting more data than ever before. Suppose that you visit a car dealership and fill out some information. All of that data is automatically entered into a computer and combined with the data from hundreds of dealerships into one big database. Once we have that data, it's easy to use the email address that you provided when you bought that car to tie your car purchase data with your data from social media or web browsing. Suddenly, we have a very complete picture about everyone who purchased a car in the last year, their ages, their likes and dislikes, their families, their friends. This additional data can be used to predict what price you can pay for your car and what other purchases you're likely to make, or how to best sell you insurance for that new car. Data is everywhere, and it's incredibly valuable information for businesses, organizations, and governments. So how do we start to use data? In data science, we generally have 4 steps to any project. First, we collect data from many sources, such as surveys, web traffic results, geotagged social media posts, and financial transactions. Once collected, we store that data in a safe and accessible way. At this point, data is in its raw form, so the next step is to prepare data. This includes cleaning data, for instance, finding missing or duplicate values, and converting data into a more organized format. Then we explore and visualize the clean data. This could involve building dashboards to track how the data changes over time, or performing comparisons between 2 sets of data. Finally, we run experiments and predictions on the data.
Right. So this is the data science workflow, which is very important. So you need to understand very well this flow. In different documentations and different places, you might find different kind of workflows. Yeah, that's fine, because some of domains need some specific workflow mechanisms. Well, in very high level, they have given collecting data collection, then data preparation. That means you need to prepare your data set for your work. Then we have to explore and visualization data visualization for us, not for the computer, because we want to find outliers, we want to find how the data is distributed and many other things. Then only we can go for experimentations and predictions. So you can see like 1/4 of structure, the component is just focused on AI, but 3/4 of the things are focused on collecting, pre-processing, and the cleaning the data and visualization, exploring, and we want to focus on these things very well, especially the students who focus for the assessment. It's emphasizing this is not the final part. Whenever you took the data, you should focus on all these phases plus, and if you have some additional phases. A lot of students misinterpreted it. It's just take the data, then write 2 lines of code. As an example, just any most of these SQL and related packages, it's just a couple of lines, just fit method and stuff. It's much easy. What they're doing is they just run the code and send it to us. That's it. 2 lines. Seriously, for a given problem, it's just 2 lines. I don't believe. Even you don't believe, even no one is believed. So you should go through all these steps, the sequence of steps very well. Then only you have to do your final model development. Clear? So keep it in mind. It's not just implementing. We'll time to time to do some time to time we'll take some data and we'll process it. Then we'll go for many other aspects and we'll do many other things. Right? Clear? Any questions up to now of this data science work, the definitions and stuff? No? Others? All good.
Data. For example, this could involve building a system that forecasts temperature changes or performing a
They're
test
giving
to
an
find which
example.
web
I don't
page
know whether
requires
you
more
can hear
customers.
it or not. Okay.
Now you know
Here,
why data science is
machine.
important and the first 4 steps in the data science workflow. Let's explore these themes in some practical exercises.
All right, they are going for a practical, but I'm not going for a practical just now. It's cost from some data camp. Right. As discussed last time, we have a flow of data that goes through different stages. So the first one is we have to define a problem, right? We have to start and define a problem initially. Then we want to collect the data, right? We want to collect sufficient data. We want to clean the data. Then we want to perform many other relevant activities, data imputation, normalization, many other things that we want to do. That's why I just added uh, other relevant activities. Then analyzing data. You want to different kinds of analysis that we want to go for. Is there any patterns for recognition? Identifying data is in there, and many other things. Then we want to represent the result, with useful insight in a way the company can understand. Then finally, you want to take your data set to AI, which is the story that your subject focus on. Got it? So it's mandatory to understand these steps before you develop your model. I'm emphasizing this again and again. Probably each and every week I'll emphasize these things. Why? Last minute, what you do? You go to ChatGPT and ask a code, then paste it in the answer script and share it. You'll get 0 marks. I don't want to happen this to you. That's why I'm emphasizing this again and again. I'm telling this throughout these 10 weeks again and again and again. But unfortunately, I'm getting the same result every time. Last time it's not GPT. Last time it's from a GitHub code. Right? This time I'm pretty sure it's fully of ChatGPT answers, because in another institute I'm doing the same thing, but they have done the same thing. There are around 6 to 8 students probably to give up from first couple of weeks. Then out of 6, I think 5 it's ChatGPT. So 0 marks. I had to give 0 marks. I'm really worried to give 0 marks, guys. Please don't do this one. Please don't do this one. It's a pain for me. It's a pain for you. You spend a lot of money. It's your time. This is your life, right? Your young life is going to destroy for unwanted thing, and punishment is 100,000. Pay back, fine. Huh? 7,000 fine. So aparadini, right? So save your money. So no need to repeat this subject again and again. So do as much as you can. I'm telling you, don't use ChatGPT and just to go through the process very well. If you have done the process very well, it's diagrammatic implementation. No one will argue. It's clear what you have done. That's it. No need to check again and again. Once we read an answer script, we know whether this is a real answer script or a fake answer script. We don't want any tools because we have marked a lot now, so we know. But you can cheat us. Nowadays, it's not cheating us, it's cheating for you again, because you got a license, but you can't drive. You have certificates in swimming, but you can't swim. It's a purpose. No purpose, right? No point at all. So don't let it happen to this subject. Well, we'll go to the next one. Any questions? No. All right. Today I have nice face in front of me, fortunately. Right. We'll start with the data. Now we are going back and forth, right? First few days we are going to be going back and forth. You know what the reason is? The reason is you should familiar with these buzzwords, the terms and stuff. So I'm going back and forth again and again. I'm telling same thing again and again. Unless you are well confident, I'm worried to go for more detailed because I have this experience. After third week, they're asking, so what is a data set? Then I'm getting really angry. What the hell this person is asking? This person still don't know what is a data set. Right? So to avoid these circumstances, I'm telling again and again and again and again the same thing until you are get familiar. Right? What is data? My question is, what is data? Yeah, we'll go to the standard definition, unprocessed information. Well, that's good. Or something that you have. What is data? Collection of information. Well, any others? All right. I will define in my terms. Very bad definitions I have, but that's fine, right? So whatever the things that you extracted from the live environment is data. Or else, live environment means the environment that you are living. Or else, you have some extracted data, found some data, and that data is in some another stage that we can use for something else. This is the extracted raw data. Then we have took some of data to here, but still these are data because we can use this data to get some work done. If something get that work done or processed, we are telling that's information. We can take a decision or we can do something from this data. That means it's information. Information means that it's something for you. You are happy with that or you are worried with that. As an example, 32, 44, 21. These are data. You can't do anything, right? It's just 32, 44, and 21. Well, no point at all. It's just some numbers. If we give you an index number 001, 002, 003, I have given the index number. This is the mark. For number 1 got 32, number 2 got 44, number 3 got 21. Now your number is 3, so you are getting really worried. Why? Because of this data is processed. This is the data. By combining these two, now it's processed. That's why you got upset. Unless you saw this 21, hey, who cares about this 21? But it's your marks. Now it's processed. Data is processed. Now you are getting worried. We'll give some good marks for one. 82. Number 1. Oh my God, it's nice. I'm really happy with this 81. I got good marks. This one is happy. This one is worried. Same data. Some additional processing focus is going on. Hence, we have a meaning for this data. So we'll define like this. Meaningful data is known as information. Meaningless data will tell raw data. Happy with my definition? Meaningful data, information. Meaningless data, raw data. Happy with my definition? Good. Then you can add within double quotes Manisha 2023. Right? You can cite it later on. Right? Happy? So it's my definition. I'm not sure whether this definition would cover everything or not. It's not a valid academic reference at all. Right? So for now, for your understanding, what you can do is, if it is meaningful, that means information. If there's no meaning, that's in raw stage or the raw data. Right. Once it comes to this data, we have structured, semi-structured, and unstructured data. Structured data is much easy. Structured data in general terms. For simpler terms, you just think structured data means Excel sheet. Really incorrect. Sorry, it's totally incorrect. Right? It's totally incorrect. 100 out of 100. Structured data is Excel data. But what you can do is you can remember this thing, because Excel data do have all the features that covered by this structured data. That is categorized. That element has a metadata. Right? It's searchable, and we can analyze using some different kind of tools. It's not should be like digest, and we can automate it. So by thinking, okay, structured data, an example, think your head, don't tell it to someone else, right? They might kill you, especially in an interview. They'll tell, oh my God, this is totally incorrect answer. They'll kill you. So don't tell, but keep in mind, it's Excel, then give the answer, not hiding that information. You know what is hiding information? You learned. Encapsulation. You learn, right? So now your brain is going to encapsulate this information, and you just hide that only. I'm just misinterpreting all the things now, right? So you are going to hide all of this information, and the answer is based on Excel, but you are not telling that is Excel, right? So you are thinking, all right, it's tabular data. What is tabular data? New word comes to your head. Tabular data means like a table. Tabular data means like a table. Again, like Excel table. Right? Just like an Excel table. We have columns, we have rows. Those data known as tabular data. It's much easy to process, store, and understand. Everything is much easy because it's well structured. We have well defined columns and rows. Second component is semi-structured data. That means it's not fully, it's just partially structured. It's partially structured. Well, these kinds of data needs to process in very careful manner, because not unlike this structured data, semi-structured data is not completely giving an insight for us at a glance. That means we need to do some processing. How many of you do have any JSON experience? All you do have? Right, nice. So the JSON is kind of a weird structure, right? Within brackets, within curly brackets, something gone wrong, again brackets, sorry, square brackets, again square, curly brackets, key value pairs, isn't it? Those are key value pairs. So you can define the structure that you want. You can define the structure that you want, isn't it? You can the structure you want. It's not a big deal, but it's very hard to process. You can define any number of keys, any number of values. If the number of values are very high, what you can do is you can go for JSON array, or else for a JSON object. We have only two things, right? JSON objects and arrays. That's it. So what you can do is you can define whatever the structure that you want, then you can put the data to that structure. Then it's much easier. To store, once it comes to this understanding and processing, you need to be very careful because it is not well structured data. It's semi-structured. Some structure is there, but it's not kind of a Excel sheet. Now sleepy. How many of you are sleeping, guys? One is slept. No? All right. Right. Now I think you got understood what is a semi-structured data. Unstructured data is something weird. Place to place, it's different. Take my voice. Really unstructured data. It starts from a one frequency, ending with some another totally different frequency. Starting with a one speed, ending with some totally different speed. So the data distribution, if we take this frequency distribution, it's like going here and there. Unstructured data. Images, unstructured data. If we take, we can't add just a key and value and tell this is something like this. Vast variety of data combined together, then gives the output. That's the reason for this unstructured data. If we take voice, voice is not just frequency. We have frequency, we have, I don't know how many things are there. Features, lot of features collected, right? After combining all of these features, we created a voice, a concept called voice. Image also same. Colors, color depths, number of colors, hue, saturation, alpha values, lot of things are there. Even the place that we display, based on that, the output is different. As an example, if you use a very nice sophisticated display, your mobile phone, very good mobile phone, iPhone or something, then it's very clear image. But if it comes to a normal phone like myself, my phone, it's very poor phone, so it's not very clear. Clear? So this is the story of this unstructured. That's the reason behind this. If we take the structured data, we can easily see structured data. It's very well defined features and everything that we want to process. Semi-structured we have, but not too much. Unstructured data, it's totally here and there. The reason is the number of features. Lot of features are supported for one single column. As an example, for this column, one single column consists of lot of additional features. Generally, in your terms, you can tell those are metadata. Lot of metadata supports for a one. It's totally incorrect, but just for your terms, it's like kind of thing. Right. Once it comes to data science and artificial intelligence, whatever the context, or computational intelligence, or whatever the context, we should deal with structured, semi-structured, and unstructured data. Solving a question related to structured data is really easy. Semi-structured data we have to process, then we can do, yeah, we have to do some effort, then we have to go. But once it comes to unstructured data, it's an annoying work. It's really hard. We have to find lot of data because the variations are very large number of variations are there in unstructured data. Structured data variations are very limited. We don't have a lot of variations. As an example, if there are 20 columns, that's it. But once it comes to unstructured data, there might be an anonymous. We don't know how many feature columns are there. You just ask from ChatGPT how many features that they have used. If I'm not mistaken, 700 or something features that they have used for their language model. I can't remember, but some a big amount. But once it comes to this image processing, video processing and stuff, it's really annoying task a lot. That's the story of this structured, semi-structured, and unstructured data. Clear? Any questions? All good? Happy? We'll go to the next one. Big data. As name implies, it's big data. Lot of data. Yeah, good. That's a nice definition. If we have a lot of data, it is big data. Yeah, well, up to good extent, that's a good effort. But once it comes to this big data, we have to focus on 3 V's: velocity, volume, and variety. It's not just the volume. Big data, at a glance, you might think large number of data. Yeah, that's fine. That's why I told, that's fine. 1/3 covered. The volume is very high. And generated power, generating of the data should be very high. That's known as velocity. Velocity means the sense the data generated very fastly. Really? Do you have any example for this kind of a situation, a big data? Very large number of speed, the data is generated. Simply, the data generated in very fast manner. In a given second, thousands of data changes are there. Any example? Anyone? Any example? Yes, please.
Social media.
Great. Social media. Great example. Once you go to your Facebook or whatever the social media profiles, thousands of millions of people interact each and every second. Each and every second, people gives data for us, in the sense for the organization. You like, you comment, you share, all of these are data. Even you scroll, that's data. You don't believe? Scrolling is data. If you want to check my statement, I will give an example. All you need to do is you need to scroll. All you need to do is scroll. Once you are scrolling, after fifth or third, what we call post, you will get a sponsored one, an advertisement, isn't it? After one, after every fifth or third post by your friend or somewhere, next one is an advertisement. What you need to do is you just scroll, and all of a sudden you just wait for a while in that advertisement. 5 seconds, stay in that advertisement. Think it's an advertisement related to higher education. Think that advertisement is related to higher education. You stay that post. Don't scroll. Stay in that advertising post 5 seconds. Then you start scroll again. You don't want to learn what is in there. Stay. All of a sudden, Facebook algorithms identified, all right, this person is like to higher education. Hence, your all next advertisements are focused on higher education. Scrolling is data. See this, see the fine-grained situations that you are in a world. You haven't thought sometimes. You haven't thought. You have given the data for them. Advertise for me. Advertise for me. You earn money. You use myself as a view. You haven't thought. Isn't it? You give money for Facebook. It's not free of charge. Right? You give a lot of money for them. But once you scroll, stay for a while. 5 seconds is more than enough. All of a sudden, all the advertisements, all the advertisements, ACBT, ICBT, AP, all the things comes into continuously advertisements. You just search anything that that's it. Nowadays it's much more complex. I'm just giving the real example that you feel. Who develop, who recognize all of these things? Artificial intelligence, classification problems. They classified. Anyone do have a YouTube account that uploading video content or something? I have a YouTube account, and I'm earning thousands of billions of amount from the YouTube account. Right? Per month, I'm getting 1 billion around, because a lot of people are watching my sleep videos. Right? So actually, I'm uploading, guys, because my hard disk is almost full. Every month, I need to upload as much as some of thousands of things are still in draft. Some of things I'm keeping sharing as public for someone to learn. I know no one is learning from my sleepy videos, but I'm sharing because some of students do like to record something. Some of institutes, they have only physical environment, especially the national universities. We don't have online; it's restricted. So they have they are recording. What I'm telling is, don't record. My recordings are in YouTube, so you can download it and watch. Right? So that's the simplest thing. Right. I'll come to the context again. So basically, once you go to this YouTube, if you upload something, how much they intelligent means they can classify whether you are a girl or a boy based on the content that you watched. They are telling 50% of girls, 50% of boys, or something, male and female. How intelligent they are. How intelligent they are. Based on some of features, they identify this is a girl or a boy. So they know who you are. What is your age? You are in 18 to 24 or 24 to something. As an example, all my videos are watching 18 to 24. Or yeah, 18 to 24 undergraduate students. That's truth. None of older people watch my things. None of kids are watching my things. It's like around undergraduate people. That's truth. And even 50-50 percentage. I have realized, yeah, it's like 50-50 percentage should be the class community also. That's the reality. They understood everything. We haven't given any information, but they took relevant features and they have done the work in there. That's the whole story. That's why I'm telling you, it's generating thousands of millions of data by ourselves. If you watch something, then you generated the data. You just go to YouTube. They have pre-watched places. Have you seen this? You just go to YouTube video. There is a hike in there. In this most pre-watched. Yeah. They collected the data. If we keep the pointer to that place, that's the most interesting story in that movie or something. You given the data. You rewatched means you just done a small thing, right? They earn money. They keep the advertisement nearby that. They know the story. They're very well. They're very intelligent because there's people in the world they develop all of these things somehow. This is the story of this big data. If someone asks an example, keep in mind social media. It's a nice example. The other one is variety of data. Velocity, that's fine. You know, you understood. Thousands of millions of people are interacting. Variety. Variety means the various in nature. For a like, it's an integer. For a comment, it's text. For an image, it's an image, like something not non-textual information data. We have large variety of data in there. It's a velocity, volume, and variety. If you search it, it might be 5 V's, it might be 7 V's, sometimes it might be 9 and 11 V's I have seen recently. Well, I don't want to go that detailed. If you want, you can go through. I'm totally okay. I'm just focusing on very high level 3 V's. Right. Um, one point we'll discuss and we'll go for the ending of the session one. So the data mining. This is one other important technique that involves in analyzing large set of data. For the data mining, we do have to focus on different aspects. One could be like pattern recognition. Uh, that means identifying the hidden patterns from a data. But data mining do have much more stronger things. I have given bad examples for the data mining. Decision trees, clustering algorithms, naive Bayes and algorithms. So all of these are bad examples, but good to memorize. Good to memorize. But we have much more data mining algorithms available nowadays. Very strong mining algorithms. Simply, the ultimate objective is take set of data and identifying or recognizing the data, the patterns from that data. It's just like mining gold. You know, the raw gold is not purified. It's very dirty. But once it comes to the cleaning process, we have identified the most important point in this world. The important, sorry, important what you call this material in this world. Most popular material. Right. That's more than enough for you. I think you know what is data science. You know the process of data science. You know different kinds of concepts like big data, pattern mining, and other stuff. And I will give one more hint for you. For the data extraction, we have thousands of methods like interviews, questionnaires, APIs, cookies, many methods, not thousands, don't get upset. We'll assume it might be something up to some extent. Extracting data is the whole story, whole point that focus on collecting all these data. Clear? So if you have data, then only the whole story is we need to focus on extraction data from relevant places, which is most important for our question. I'll tell again what is this question, what is this data, again and again. I'll give examples as much as you guys to understand what is this context and what is happening in here. Right? Any questions?
What is meant by clustering data?
Clustering means like think as an example, you have what we call a bucket that consists of balls, red balls and blue balls. What you want to do is you want to divide into two parts. What is red balls and blue balls? That is known as clustering. You cluster it to different based on the different features into different categories. It's categorization mechanism. Separating into clustering. We have clustering algorithm and stuff. We'll do k-means and stuff. We'll do some codes and we'll see what happens in here and there, what is going on in these places. All good. Any other? Do you have any questions? No. All right, then you can go for a break. We don't have a lengthy break. You should come at 1 o'clock. Right. So we have perfectly 29 minutes. Go eat, have 7 minutes nap, and come to the class. All right. Then we'll continue the discussion again.